Now we're going to move into some practice problems. And for these practice problems, for the most part, we're going to be working with Apple and presuming that Apple is a monopolist. And we'll be working with the demand and marginal cost as it's depicted here in this slide. Okay, so if you want a visual reference, aside from what I'll draw in these practice problems, you can use the images on this slide as well as any others referring to iPads in this slide deck. So if we go ahead and move over to our notebook, we can jump into some of these practice problems. All right, so we're going to again look at Apple, who we're saying is a monopolist in the market for iPads. So we have Apple in the market for iPads. And Apple's demand initially for problem 1 here is given as quantity demanded equal to 200 minus 0.2 times the price. Okay. And their marginal cost is given as 200. So if we go ahead and solve for our inverse demand equation, we can see that we're given the same demand curve that you saw depicted in the graph on the slide. So to do that, we're going to add 0.2 times the price to both sides. That gives us 0.2 times the price plus quantity equal to 200. We'll subtract quantity from both sides. That gives us 0.2 times the price equal to 200 minus the quantity. And then we're going to divide both sides by 0.2. 0.2 is the same as 1/5. So you can just imagine that we're multiplying both sides by 5 if that's easier for you. And so that means that we get an inverse demand equation of price equal to 1,000 minus 5 times quantity. So we can see that our demand choke price is $1,000 because when quantity is 0, price is 1,000, right? And we can see, referring back to our initial demand equation, that when price is 0, quantity is 200. And so we can very easily graph our demand curve here. And so that choke price is going to be 1,000 and quantity will be 200. And there's our demand curve. And we know that our marginal revenue curve is going to be under that. So I'm going to go ahead and draw that in. But what we're going to need to find is its intercept, right? I'm also going to go ahead and draw in our marginal cost curve. It's constant at 200. Obviously, this graph isn't to scale, but we're just going to go with it. Okay. So first off, what we want to do here is find Apple's profit maximizing output and the price that they're going to charge for each iPad. So remember, for our monopoly, their profit maximizing output is where marginal revenue equals marginal cost. And we have marginal cost, but we don't have their marginal revenue. So that's what we need to find. So remember that marginal revenue is given as A minus 2 times B times quantity. And the inverse demand equation is given as price equal to A minus B times Q. So if we look back at our inverse demand equation, we see that 1,000 is A and 5 is B. So what we can go ahead and do is find our marginal revenue equation. A is 1,000, so we have marginal revenue equal to 1,000 minus 2 times B. B is 5, so we substitute 5 for B, times quantity. So simplifying, we get that Apple's marginal revenue is 1,000 minus 10 times Q. All right, and now we can set marginal revenue equal to marginal cost and solve for output. So we'll have 1,000 minus 10 times Q equal to 200. We're going to add 10 times Q to both sides. That gives us 1,000 equal to 200 plus 10 times Q. Then we'll subtract 200 from both sides. That gives us 800 equal to 10 times quantity. We're going to divide both sides by 10. And we get 80 equal to quantity. And one thing I forgot to mention here, just like in the graphs, we're going to have quantity measured in millions. All right. So we know that that point where marginal revenue equals marginal cost is going to be 80 million. And if we were to solve for quantity when marginal revenue is 0, we would find that marginal revenue is intersects quantity at 100. A little shortcut to know this, whenever you have a linear demand curve, because marginal revenue will have twice the slope, right? That 2 times B relationship to demand. That means that marginal revenue is going to bisect the segment of our quantity axis between the origin and where demand intercepts it, right? So it's always going to be half demand. Okay, so we have the quantity that Apple will produce when its marginal costs are at 200, given its demand equation. Now we just need to find the price. So we need to know what will Apple charge. So we know they're going to mark up above that marginal cost curve, and it's going to be constrained by demand. So what are consumers willing to pay for the 80 million iPads? So what we're going to do is just substitute for quantity in our inverse demand equation. So we'll have price equal to 1,000 minus 5 times quantity, and we'll substitute 80 for quantity. So we have 1,000 minus 5 times 80. That gives us 1,000 minus 400. So that price that they're going to charge for each iPad is $600. All right, and hopefully you're recognizing that this is a graph we were working with before on the slide. All right, so you can see how we're getting those values, those same values from our givens in this problem. Next, what we want to do is find the distribution of surplus. So what is their consumer surplus, producer surplus, and deadweight loss in this market, right, in this monopoly market? So our consumer surplus is our top blue triangle here. Our producer surplus is this green rectangle. And deadweight loss I'm going to depict with a pink pen here. So it's this pink triangle. Okay, so to start with consumer surplus, we're going to solve for the area of that triangle. So we'll have our height is 1,000 minus 600, and our base is that 80 million produced and sold. So consumer surplus is equal to 1/2 times 80 minus 0, 0, times the difference between the demand choke price and the price that the monopolist charges. Simplifying, we get 1/2 times 80 times 400. 80 divided by 2 gives us 40, so we have 40 times 400. So that's going to give us consumer surplus of 16,000, and then we're going to multiply that by million, so it's going to actually be $16 billion for our consumer billion surplus. Right, and we multiply by a million because quantity is measured in millions. All right, so we don't want to forget that. Oops, sorry about that. All right, now let's find our producer surplus. So our producer surplus is our green rectangle here. So we'll have length times width. So we'll have the length of 600 minus 200 and the width of 80 million that are traded and sold. So we have, again, 600, so that price that the monopolist charges minus the marginal cost times the amount exchanged. Simplifying gets us 400 times 80, which gets us 32,000. Multiply by the million because quantity is measured in millions, and we get 32 billion for our producer surplus. Lastly, we need to find deadweight loss. And as a reminder, the reason we have deadweight loss in this market is because we're implicitly comparing this market to the perfectly competitive one. So we're saying there's less output here than there would be if this market was perfectly competitive, and so there's deadweight loss, right? There's fewer iPads traded. So to find deadweight loss, we need to find the amount of output produced under perfect competition. So we know that in perfect competition, firms produce where price equals marginal cost, All right. So what we're going to do is set price equal to marginal cost, right? We have that since we have the firm's inverse demand equation. So we'll have 1,000 minus 5 times Q equal to 200, and we're just going to solve for quantity. So we'll add 5 times Q to both sides. It gives us 1,000 equal to 200 plus 5 times Q. Then we'll subtract 200 from both sides. That gives us 800 equal to 5 times Q. And then we'll divide both sides by 5. So doing that, that's going to give us 160 million iPads being produced in perfect competition. So let's go ahead and write that in to our graph, right, for our perfectly competitive value. Okay. And you can see that that's twice what the monopolist is producing, and that's because for our perfectly competitive firm, their marginal revenue curve is equal to the demand curve, right? So their marginal revenue is twice that of the monopolist. Okay, so now we have everything to find deadweight loss. We're going to find that area of the triangle. It's the difference between the price that the monopolist charges and the price that is charged in perfect competition, which is marginal cost. And then the difference between what is produced in perfect competition, so 160 million, and subtracting from that what's produced under monopoly, which is 80 million, and all times 1/2 because we have a triangle. So simplifying, we get 1/2 times 400 times 80. 1/2 of 80 is 40, so we have 400 times 40. So that means that our deadweight loss is 16,000, but we need to multiply by 1 million because our quantity is measured in millions. And so deadweight loss is $16 million, just like consumer surplus, excuse me, billion. Okay. All right. So there is our distribution of surplus. What we might want to do is say, okay, now I really want to know what our perfectly competitive firm would look like. And so what you would do is say, all right, the Apple's profit maximizing amount in perfect competition would be that 160 amount, and their price would be equal to marginal cost, so their price is 200. So just knowing those relationships, you could find the values that way, or you could follow the same process as we did before, set price equal to marginal cost, find output of 160, and then substitute for that output in the firm's demand equation, and you would get a price of $200, okay? If you're able to remember those relationships, however, it makes it a lot easier to make that jump between the two types of markets than having to do all that math again. All right, so let's find their distribution, the distribution of surplus when Apple is a perfectly competitive firm, so we can compare it to when it is a monopolist. So I'm just denoting here all our monopoly values before we move on to perfect competition. So in perfect competition, our output again is 160 at a price of 200. So our consumer surplus is going to be much larger in this market. And in fact, it's going to be the entire market, right? That difference between the price that consumers pay and that what they value the good at is our entire surplus here. So we could just add consumer surplus, producer surplus, and deadweight loss. But for the sake of practice, I'm going to go ahead and walk through the area of our demand, our area of our consumer surplus triangle. So we'll have consumer surplus equal to 1/2 times the difference between the demand choke price and the price charged in perfect competition, which is $200, times the amount produced under perfect competition, which is 160. Simplifying, we get 1/2 times 800 times 160. 160 divided by 2 is 80, so we get 800 times 80. That gives us 64,000, which we multiply by 1 million because quantity is measured in millions. So we have that consumer surplus under perfect competition is 64 billion, which is what you should have gotten if you instead added 16 billion plus 32 billion plus 16 billion, right? 16 plus 16 is 32. 32 plus 32 is 64, right? So we have those same values, okay? Now let's consider producer surplus. So if all of the surplus goes to consumers in perfect competition, then that means for producers, there's nothing left, right? Their producer surplus is 0. And then for deadweight loss in perfect competition, because the perfectly competitive market is serving as our counterfactual for the monopoly model, we're also considering that there's now the full amount that should be produced, quote unquote, should be produced, is being produced. So deadweight loss is 0. All right. So now that we've compared monopoly to perfect competition, let's see what happens if Apple's demand for their iPads changes. So let's say it changes such that quantity demanded is now equal to 280 minus 0.2 times the price. And marginal cost is stayed the same at $200, right? We're going to solve for our inverse demand equation again. So we'll have 0.2 times the price added to both sides. That gives us 0.2 times the price plus quantity equal to 280. Then we'll subtract quantity from both sides. So we get 0.2 times the price equal to 280 minus quantity. And then we'll divide both sides by 0.2, which again is the same thing as multiplying by 5. Okay. So when we do that, we're going to end up with an inverse demand equation of price equal to 1,400 minus 5 times quantity. Okay. And I'm actually going to change my color here so we can draw this into our graph. I'll go ahead and use red, I suppose, or maybe purple. Purple might be good. Let's use purple. So we'll have our new demand equation, inverse demand equation, is price equal to 1,400 minus 5 times Q. So let's go ahead and draw that into our previous graph. So that means that our choke price is now 1,400, and our demand curve is now intersecting the quantity axis at 280. So our curve has shifted out. All right. So now that we have our new curve, we need to find our new marginal revenue curve. So we have our new demand curve, we need our new marginal revenue curve. So for our new demand equation here, our value for A is 1,400 and our value for B is 5. So for marginal revenue, we knew it's A minus 2 times B times quantity. So substituting our values, we'll have marginal revenue is equal to 14 minus 2 times 5 times quantity. So that gives us marginal revenue equal to 1,400 minus 10 times output. Okay, so that means we can draw in our marginal revenue curve here, starting also at that 1,400 point, and it's actually going to, intersect our quantity axis at 140. Right, so there you go. So you have both marginal revenue and demand shifting, right? When demand changes, marginal revenue is also going to change. So that means that our firm is going to have a new profit maximizing level of output, as well as a new price that they'll charge for their product. So let's go ahead and solve for those values. So profit maximization is defined for our firm as where marginal revenue equals marginal cost. So we'll have 1,400 minus 10 times quantity equal to 200. To solve for quantity, we're going to add 10 times Q to both sides. That gives us 1,400 equal to 200 plus 10 times Q. Then we'll subtract 200 from both sides, giving us 1,200 equal to 10 times quantity. And then our last step here will be to divide both sides by 10. So we get 120 equal to quantity, right? And of course, this is in millions, right? Just keep that in mind. So we can draw this new profit maximizing amount on our graph. It'll be 120. And then we want to find what price does our firm charge with this change in demand. So price now is equal to 1,400 minus, minus 5 times quantity. And we found quantity to be 120. So we're just going to simplify. So we'll have 1,400 minus 5 times 120. So that's going to go ahead and give us 600, meaning that the price that Apple now charges for these iPads is $800. So now we have that $800 written in. All right. So let's see how our surplus has changed with this change in demand. So our producer surplus is still going to be present. It's going to be this now larger triangle, right? There's now this greater difference between the marginal cost of the firm and the price that they can sell their goods at. And then for consumers, it's going to be the triangle above producer surplus, and we will have some deadweight loss. All right, so let's go ahead and find these values. So consumer surplus is that top triangle. We'll have it equal to 1/2 times the difference between the demand choke price and the price that the monopolist charges. So 1,400 minus 800 times the amount sold, which is now 120. Simplifying, we get 1/2 times 600 times 120. Half of 120 is 60, so we get 600 times 60, and then that leaves us with 36,000. And because quantity is measured in millions, that's actually $36 billion for consumer surplus. Producer surplus is going to be the area of our larger green rectangle. It's going to be the difference between the price that consumers now pay and the firm's marginal cost times the amount traded, which is now 120. So we'll have producer surplus equal to 800 minus 200 times 120. So that gives us 600 times 120, right? And that's going to give us 72,000 times 1 million, since quantity is measured in millions, which means that we get $72 billion for producer surplus. Lastly, here we want to find deadweight loss. So deadweight loss is our triangle that shows how much less is being produced by our monopoly than would be produced by a perfectly competitive firm. It's going to be the difference between the price that consumers pay and the marginal costs of the firm, and then the difference between what a perfectly competitive firm would make compared to a monopoly, right? So our monopoly here is making 20 million iPads, and we want to know what our perfectly competitive firm would make at this under this demand system. So we're going to set price equal to marginal costs. That's going to give us 1,400 minus 5 times Q equal to 200. And we're just going to solve for Q. So we'll add 5Q to both sides. That gives us 1,400 equal to 200 plus 5 times quantity. Then we'll subtract 200 from both sides. That gives us 1,200 equal to 5 times Q. And then our last step here is to divide both sides by 5. Okay, so that gives us quantity under perfect competition. There we go. Is going to be equal to 240 million. Whoops, sorry. Shifted the window when I was trying to circle that. Okay, 240 million iPads being produced. So we can go ahead and write that into our graph. It's 240. It's twice what the monopolist produces. So you could have anticipated that value as well. So deadweight loss will be 1/2 times the difference in price that the monopolist charges and the price that the perfectly competitive firm would charge, which is 200, right? It's equal to the marginal cost. And then we're going to multiply that by the difference between what the perfectly competitive firm makes and what the monopolist makes, which is 240 minus 120. Simplifying gives us 1/2 times 600 times 120. From there, 1/2 of 120 is 60, so we get 600 times 60, so 36,000 times million, because quantity is measured in millions. And so deadweight loss here is $60 billion, right? Just like consumer surplus. They're symmetric in this case. All right. So now we've done a bit given monopoly market. We have compared the output and price and distribution of surplus in the perfectly competitive market and the monopoly market. Then we've had demand increase, and we've seen how that's changed our market. And now what we want to do is say that, let's say their demand changes again, but so does their marginal cost. So now it's double what it was. So we'll go ahead and draw a new graph because our previous one was getting a little messy. So let's see here. We have a demand change. Quantity demanded is equal to 400 minus 0.4 times the price. And we have a marginal cost change. Marginal cost change. It's also doubled, so marginal cost is now equal to 400. All right. So let's start by finding our inverse demand equation. So we'll rewrite our given equation for demand. Quantity demanded is equal to 400 minus 0.4 times the price. And we're going to solve for that price. So we'll add 0.4 times the price to both sides. That gives us 0.4 times the price plus quantity equal to 400. Then we'll subtract quantity from both sides. So we have 0.4 times the price equal to 400 minus quantity. And then our last step here is going to be to divide by 0.4. And divide by 0.4. That's the same as multiplying by 5/2, right? So that's going to give us price equal to 1,000 minus 2.5 times quantity. Okay. So if we draw our graph here, we have again a choke price of 1,000, but now our quantity axis intercept is 400. Let me try to draw that demand curve again. Okay. And our marginal cost is double what it was at 400. All right, so to find our marginal revenue curve, what we're going to do is double our slope, right? Because we have marginal revenue is equal to A minus 2 times B times quantity. A is 1,000, B is 2.5. So marginal revenue in this case is 1,000 minus 2 times 2.5 times quantity. So we have marginal revenue equal to 1,000 minus 5 times quantity. Okay, so we can draw in our marginal revenue curve. And it's going to bisect our quantity axis here. And now we can go ahead and solve for the firm's profit maximizing values. So we'll start by setting marginal revenue equal to marginal cost. So that'll give us 1,000 minus 5 times quantity equal to 200. We're going to solve for Q, so we'll add 5 times quantity to both sides. That gives us 1,000 equal to 200 plus 5 times Q. Then we'll subtract 200 from both sides. That's going to get us 800 equal to 5 times quantity. Then our last step will be to divide both sides by 5. So we're going to go ahead and get 1 and then 180 for our maximizing amount of output for our firm. So again, this is measured in millions, so it's actually 180 million iPads that Apple is producing. And then we want to know what price do they charge. So we're going to substitute for quantity in our price equation, right? Our demand equation. So we'll have 1,000 minus 2.5 times 180. So price is going to be, let's see, so 180 twice is going to give us 360 plus 90 is going to give us 450. Let me just check that. Yep. So we'll have price equal to 1,000 minus 450. So that means that we're going to have a price of $550. Oops. All right. Now we can find the distribution of surplus. So consumer surplus is our top triangle, producer surplus is our rectangle, and deadweight loss is our triangle, showing the difference in output between perfect competition and monopoly. So consumer surplus here will have 1/2 times 1,000 minus 550 times 180 minus 0. That gives us 1/2 times 450 times 180. That gives us 450 times 90. All right, and 450 times 90 is going to give us 40,500 times 1 million, since quantity is measured in millions. So we're going to get $40.5 billion for consumer surplus. Producer surplus is going to be our green rectangle, and we'll get that by subtracting 400 from 550 and multiplying by the amount of iPads traded. That's going to get us 150 times 180. And doing that math, we get 27,000 times 1 million means that we have 27 billion for our producer surplus. And then lastly here, we want to know our deadweight loss. So first we have to find how much our perfectly competitive firm would produce. So we'll have 1,000 minus 2.5 times Q equal to 400. We're going to add 2.5 times Q to both sides, right? We're solving for quantity. So we get 1,000 equal to 400 plus 2.5 times quantity. Subtract 400 from both sides. We'll get 600 equal to 2.5 times quantity. And then we'll divide both sides by 2.5, which is the same as multiplying by 2 halves. Okay. So 600 multiplied by 2 halves or divided by 2.5 is going to give us, should give us twice what we found before, but I got 240. Okay, so that 240 is correct. I actually made a mistake earlier where 800 divided by 5 is 120. So that means that our price for our firm here should not be 550. It should instead be 700. That makes a little more sense. Okay, so this is be 300, 700. Sorry about that. And then when we go back, our consumer surplus is going to change. So we'll have 1/2 times 1,000 minus 700 times 180. That gives us 1/2 times 300 times 180. So 300 times 90. That's going to give us, whoops, 27,000. When we multiply by a million, would be 27 billion. All right, so we need to correct that. So just make sure you note that. And then for our producer surplus again, we'll need to change that. So we'll have, whoops, yeah, 700 minus 400, which gives us 300 times 180. So that's going to give us 54,000 times the million for our units, and so we get 54 billion. That makes more sense than what we had before. Okay. All right, so sorry about that, everyone. I hope you're able to catch that change. Now let's finish up with deadweight loss. So for deadweight loss, we've now found our amount that firms produce under perfect competition. It's going to be 240. Okay. So our deadweight loss triangle then is going to be defined, the area of it will be 1/2 times 700 minus 400 times 240 minus 120. So that gives us 1/2 times 300 times 120. Half of 120 is 60, so you get 300 times 60, which gives us 18,000 times the million that our units are measured in, and deadweight loss is $18 billion. Okay. All right. And so with that, that's going to end our practice problems for Monopoly. And we'll pick up with our next video.